The topic is evaluating the double integrals by converting to polar coordinates. So let's do this example. We need to evaluate the double integral where x goes from 0 to 4, because there's a dx there outside. So x is between 0 and 4, and because the inner integral has a dy, now the y goes from 0 to square root of negative x squared plus 4x. Alright, so let's try to draw our region. So first we need to know how does y equal, let me rewrite it here, y equal square root minus x squared plus 4x. How does the graph look like? So let's square both sides. If we square both sides, we get y squared is equal negative x squared plus 4x. Now let's move this to this side. That would be x squared minus 4x plus y squared is equal 0. Let's complete the squared. X squared minus 4x plus 4 divided by 2 is 2. 2 squared. Add 2 squared to the other side. Now this becomes x minus 2 squared plus y squared is equal 4. So this is actually circle. Let me draw the whole circle. This is a circle with center to 0 and then radius equal 2. So this is 2, 4. So actually, that's how the circle look like. Right? However, remember, if you solve for y, you will get minus or plus square root. If you go backwards, because of a y squared, y will be minus or plus square root of negative x squared plus 4x. But the positive one will be the upper half of the circle, so this will be y equal, is that what we need? Yep. Square root minus x squared plus 4x. The bottom one will be the minus square root. We don't need it, but let me just write it. The bottom half is y equal negative square root minus x squared plus 4x. So the x is going from 0 to 4, from here to here, but the y is only going from 0 to the upper, to square root of negative x squared plus 4. So actually, to convert, let me call this integral 1. Integral 1 will be, the theta should go from here, which is 0, right, to pi over 2, right? It's going from here to here. So the theta is going from 0 to pi over 2. But the radius is going from here to here. Don't confuse that. It's not, the radius is not going from 0 to 2. So how do we know the radius? Let's go back to, let's go back here. Y squared is equal minus x squared plus 4x. Let's move this to the other side. X squared plus y squared will be equal 4x. Now I can replace this by r squared, and then x is r cosine theta. Now let's divide both by r. I'm going to get r equal 4 cosine theta. So actually the equation in polar will be r equal 4 cosine theta. So the r will go from 0 to 4 cosine theta, and then that's square root x squared plus y squared. Again, it's r squared And don't forget, these are r dr d theta. So r dr d theta, which is equal to, this is going to be r times r is r 1/2. So the integral will be, what did we say, r squared. So it will be r3/3 between 0 and 4 cosine theta d theta, which is equal to, plug in the cosine, that would be 4 cube cosine cube theta, well, over 3 cubed, over 3, right? And then minus, plug in a 0, you're just going to get a 0, so we don't have to write it. Minus a 0, and it's d theta. Make sure we didn't mess up. R2 R3/3. Yeah. Now we're trying, so 4 times 4 is 16. 16 times 4, I think it's 64. So let's take 64/3 outside. Now because this is odd, I'm going to write it as cosine square of theta times times cosine theta, right? But cosine square is 1 minus sine square, so 1 minus sine square theta cosine theta d theta. Now if I call my u to be sine theta, the du is automatically going to be cosine theta d theta. So the integral becomes 0 pi over 2 1 minus u squared du, which is equal to u minus u3/3 between theta goes from 0 to pi over 2, forget 64/3, which is 64/3. My u happens to be sine, so sine of theta minus sine cube of theta over 3, and you want that to go from 0 to pi over 2. Almost done. This will be 64/3. Sine of pi over 2 is 1. Sine of pi over 2 is also 1, so minus 1/3 minus, if you plug a 0, you get 0 minus 0. 1 minus 1/3 is 2/3, so this will be 64/3 times 2/3, which is 128/9. And that's it for this example.